Students, I hope you will be okay. In this track, we want to speak about CLBs, configurable logic block, about the structure of CLBs. As we know, we say that each CLB can implement any logic function, but how this happens? At first, please see the figure at left side. As you can see, we have a figure and it starts with three LUT lookup table, full adder and D flip-flop. Okay, we start by lookup table. What is the lookup table? The lookup table is really composed or made by a memory, SRAM memory. This SRAM memory has 1 bit data in each cell or in each address, but the number of address is equal to the inputs. For example, if we write 3 lookup table, it means that the inputs are 3 inputs, or the number of inputs are 3, A, B, C, for example. Then we have 3 input A, B, C. If we have 3 input, it means that we have 8 cells in this memory, and each cell is 1 bit. Okay, if we write in this memory, it means that we map each address to one value, to one logic value. For example, we map 000 address, 0 address to, for example, one logic function, high logic. If we address, for example, cell number 1 to another high, cell number 2 to 0, to low, cell number 3 to low, cell number 4, for example, to high, and etc. It means that we really implement a logic function by writing in a memory. Then by writing in a memory a 1 bit or 1 bit in each cell memory, we can implement any logic function, but any logic function with 3 inputs. Then 3 lookup table, it means that we can implement a logic function with 3 inputs. Each logic function, and it depends to the VHDL code that we write. As you can see, we have two 3 lookup tables. It means that we can implement 2 different logic functions in this FPGA and in this CLB. And then we have a full adder. It means that we can implement some arithmetic functions or some arithmetic operations. Then in the first stage we can implement logic functions. In the second stage we can implement arithmetic functions or arithmetic operations. And after all we can select or we can choose one of these functions as the output of these or these multiplexers. At the third stage we have a D flip-flop. And as you can see, we have a multiplexer to select the output, the final output of CLB. The final output of CLB can be the output of D flip-flop or can be the output of logic functions. It means that we can implement both sequential or combinational logics. If we want to implement only combinational logics, it means that we don't need 2 memory cells. Then we can omit or bypass the D flip-flop. If we can or if we need to sequential logic, then we can select the output of the flip-flop as the final output of the CLB. The figure in right side